Good morning, pre-algebra students. In this video, we're going to check your review for the Chapter 5 test. Test is coming up tomorrow, so remember, just like usual, we will check your review. You'll take it home and study from it, and then you'll bring it back tomorrow and turn it in before you take the test. So we're going to start by solving a system of linear equations by graphing. Just remember that when you graph an equation, you want your equation to be in slope-intercept form, where m is your slope and b is your y-intercept. So remember, you start by plotting your y-intercept first and then using your slope to find other points on the line. The graph of equation number 1, as you can see, creates two parallel lines. Therefore, there is no solution. Remember, when you have the same slope in your equation and different y-intercepts, you're always going to end up with a no solution. The graph of number 2 has a solution of 3, 3, which is right here. Moving forward, graph number 3 has a solution of 1, 1, right there. Looking at equations in number 4, notice that both equations are in standard form. So the first thing you want to do is change both equations into slope-intercept form so you can easily identify your slope and your y-intercept, which I've done for you here. Here's the graph of those two lines. The solution is 2, 2. In number 5, you can see that your solution is way down here. It is at -1, -3. And the graph of the two equations in number 6 produces the solution -4, 4. Okay, so if you turn to page 2, you can see that now we're going to solve our system by using substitution. Please make sure that you do follow directions and use the correct method. In equation 5, we're going to take the equation in the top here, the x plus 3, substitute it in place of y in the second equation, solving for x, and then using that value of x to plug it back in and solve for y, we get a solution of 3, 6. For equation number 6, notice y is already isolated in the second equation, so we're going to plug the 2x plus 4 in place of y in the first equation, solve for x, and then use that value to substitute and solve for y, getting a solution of 1, 6. In equations number 7, notice y is already isolated in the second equation, so we're going to plug that in place of y in the first equation. Be careful on this one when distributing. Remember, you are distributing a negative here, so you have to make sure you watch your signs. Solve for x, and then plug that back in and solve for y. Your solution is -3, 3. Don't forget, you can always check your solutions by plugging them in and checking them in the original equation. Okay, moving on to the next 3. This time we're solving by elimination. Remember, we use elimination when both equations are already in standard form, so x and y are on the same side. Remember, first we want to decide if we should add or subtract. We add if our variable containing the common coefficient has this opposite signs. We do subtract if they have the same sign. So like here, they were both negative, so we're going to subtract. But when we subtract, we change our subtraction to addition, and we change everything inside the parentheses to its opposite. So everything in the second row goes to its opposite signs, solve for x, and then you use substitution to plug that back in and solve for y. I generally just substitute right back in the first equation, but you can always choose. Solution for number 8 is -1, -5. In equation 9, our common coefficient is 2. Those were the same sign again, so we're going to subtract. Solve for y, substitute it back in and solve for x. Our solution is 4, 10. In problem number 10, our common coefficient is 2 for our y term, and as you can see, these are opposite signs, so I'm going to add. I solved for x, and then I substituted that in place of x in the first equation and solved for y, giving me a solution of 4, -3. Okay, so this next section is what we were working on in that last section 4, 5. And the idea here is that you're going to solve the system and decide if it's got a one solution, a no solution, or infinitely many, and then explain your reasoning. And really, like I said here, you're explaining your reasoning, so you don't really need to show work if you understand how to determine the number of solutions without doing so. So for number 11, I went ahead and did solve this system. It was a little messy, but as you can see, your two equations when in slope-intercept form have different slopes and different y-intercepts. When that happens, it's always going to give you a 1 solution. In problem number 12, I multiplied the first equation by 2, which gave me equivalent equations. You could also divide the second equation by 2, putting that into slope-intercept form, which probably would have been easier. And then you could see that the second equation would also give you y equals 4x plus 6. When two equations have the same slope and the same y-intercept, that's always going to give you infinitely many solutions. And in number 13, both equations are already in slope-intercept form, and I can see this time that I do have the same slope in both equations, but different y-intercepts. So this is automatically going to be a no solution. Remember, if you were to graph these, it would give you 2 parallel lines. Okay, so now we're looking at page 3 of your review, and notice directions this time do specifically say to solve, and then you want to determine if there's one solution, no solution, or infinitely many. So this time you do absolutely have to have some work to support your answers. So notice in number 14, I chose to substitute because the y is already isolated in the second equation. So I'm plugging in place of y in the first and solving. Automatically, I can see that my variable terms drop out, giving me a solution of negative 6 equals 7. So I said that's false, therefore there's no solution. In number 15, notice both equations are already in standard form, so I chose to use elimination. My common coefficient is on my x term here, and they're opposite signs, so I'm choosing to add, and when I do, all of those opposites end up canceling out, so I get a solution of 0 equals 0, which is a true statement, so I said infinitely many solutions. Number 16, y is already isolated in the first equation, so notice I'm using substitution, and I'm going to substitute that in place of y in the second equation and solve. Notice this time I get a 1 solution, and it is 1, negative 1, and you should show that. Okay, so moving on, we have our 2 word problems here. Let's take a look at those. Notice first of all, I've read through the problem. I've identified some of my important information here, and then I've kind of broken it down into steps for you. So my first step was to decide what my variable terms are going to be. So I said let x equal the number of adult tickets and y is going to be the number of children tickets. The second thing I'm going to do is set up my 2 equations for my system, and you have to show both equations. So I have a total of 7 tickets, so that's why I'm using this first equation, x plus y equals 7. The second equation is my cost equation. So notice I'm using everything that has a dollar sign attached to it in my second equation. So it says I have adult tickets are $12, so that's this, and children's tickets are $9 for a total of $72. So that's how I came up with my second equation. And then I'm isolated y in my first equation by subtracting x from both sides. So step 3 is using substitution. I substituted this expression in place of y, and then I used that to solve and then plugged it back in and found y. So my final answer, which is in step 4, remember this time instead of giving an ordered pair, I want to clearly state an answer with labels. So I said they bought 3 adult and 4 children's tickets. And number 18, we are back to one of those farmhouse problems. We did several of these together, so you should be pretty good at them by now. Number 1 is my variable statement. You can use x and y every time if you want. Just for fun, I said let c equal the number of chickens, p equal the number of pigs. It's helpful for me to use a meaningful variable so I can kind of keep them straight in the problem. So number 2 says the number of chickens plus the number of pigs has to equal the 13 animals that are in the barn. My second equation, the 2 came from the 2 legs that chickens have plus the 4 legs that pigs have has to equal a total of 40 legs. So again, I isolated one of the variables in the first equation. I substituted 13 minus p in place of c in the second equation and then used that to solve. And then I substituted again to find the second variable. In step 4, I clearly stated my answer saying there are 6 chickens and 7 pigs in the barn. Okay, so we have a couple of multiple choice to round out your review. You will have some questions similar to this on the test, but notice even though it's a multiple choice question, you do have to have work to somehow support your answer, support your thinking. So in number 19, I noticed right away that these two equations were in standard form, so I was going to use elimination. Once I eliminated y, I got a value of x equals 2, and if you notice, by process of elimination, I got rid of a and c because the only ones that have x equals 2 is b and d. So I did go ahead and solve for y then, and then that allowed me to see that the correct solution was answer D and not B. In equation 20, this time the first equation is in slope-intercept form, so I used substitution this time. I substituted my x minus 4 in place of y, and then I solved, noticing that that gave me a solution of x equals negative 2. Again, I used process of elimination to get rid of a and d because those were different values for x, and then went ahead and plugged it in to find my value of y, which was negative 6, therefore giving me the correct answer B. So again, on these, make sure that you're using, choosing a system or a method of solving that makes sense, okay? So good luck. Study everything for your test tomorrow, and I know you guys are going to do great.